So AI is changing the way we develop applications, and you know this, and you don't need a bunch of fancy Harvard and VentureBeat and Gartner, proof points to know this. You're experiencing it yourselves. So we know this, but why we should build applications is not changing. So we're still trying to solve some kind of business problem, map a business process to a particular solution, come up with answers to questions. So fundamentally, we're still trying to solve for business problems. Obviously, we have a whole bunch of new tools. And so, what are the things that are changing? So, one, from a data perspective, is we're moving from a world of having predefined workflows where you have simple CRUD data models, create, read, update, delete, to dynamic, context-aware, and autonomous applications. So agents that coordinate with each other, make real-time decisions, are more proactive, don't behave as a function of like code and predefined rules, and importantly, have an understanding and operate based on context about both the subject that the object that you're treating and the subject that is treating it. So like who the customer is and who the individual is maybe inside of a company that's a stakeholder for something. And really, if I drill down into that, there are five specific patterns that are changing. So one is going from static logic to dynamic reasoning. And so in the old world, this comes back to the CRUD point and hard-coded rules that are defined at compile time, like when you code and compile. And what we want to be able to move to is being able to reason, adapt, make real-time decisions, and importantly, focus on fulfilling a number of goals with maybe more open-endedness as to how you're going to fulfill it. Number two, it's going from just sheer request response to being more goal-oriented. So here, I'm just reacting to user input in the old world, whereas here, I might be more proactive in pursuing a set of goals, orchestrating tasks, and even operating with other agents that each are solving their own micro goals in order to solve some larger macro goal. And I also want to be able to adapt and learn from feedback. You're also moving a bit more from monoliths. So granted, you've had microservices, but composable systems actually are even more flexible and kind of the next level beyond, certainly beyond monoliths, but even beyond microservices. So you're going from tightly coupled architectures where you know in advance how things are going to interact in what order, to having different agents that might interact with each other in different ways that come into being almost in real time as the situation is unfolding. This one's kind of an obvious change as well, is moving from being code-centric to being more prompt-driven. And then last but not least, going from CRUD. So I'm going to retrieve a particular information just about the thing that I care about, to understanding, well, what are the goals of that thing? What are the interactions? What are the ways in which that thing fits into the world? And that's context. So these are ways in which software engineering is changing. Now, how's the data layer changing? What does it mean for the data layer to be able to support these kinds of requirements? Particularly in a world where today most data is still stored in rows and columns, which can be okay for certain kinds of use cases, but if it's spread across silos and you're needing to add data regularly to take on new kinds of problems, then that abstraction isn't necessarily the best for the kinds of AI knowledge that we're working with. Works well when you're structured for static data and relatively fixed questions, but a bit less the more open-endedness which you have, and there is quite a lot there. So what are the requirements then, now that we've talked about the requirements and how application development is shifting for agentic enterprise knowledge? What knowledge do these agents need, and in what form, in order to be able to go about and fulfill all these requirements? The first is you need to be able to have real-time updates and low latency retrievals, meaning I can't have my knowledge in the model where, like, I might have some world knowledge in the model. That's always useful. But knowledge about my business domain, like, I'm not going to have my model as the source because my model only knows about the data that it's been trained on, which could be out of date. And then the model isn't always able to provide super low latency interactions. Number two is you want to be able to store structured data, but also semi-structured and unstructured. So a lot of value in unstructured, which is part of what the agentic and AI revolution is all about. You also want to be able to span across silos because, yes, I can have maybe a very narrow AI that solves for a particular narrow problem inside the company. But really, the holy grail here with AI is using as much of the company's knowledge as possible about a customer, about products, partners, supply chain, and so on and so forth, other actors, competitors, people in the company. The more you have access to that for each agentic decision uh, within the scope of what's appropriate and legal to use in a particular scenario, so then we get to access controls down the road, um, is the more access you have to all the data in the enterprise, the better you're going to be able to have intelligent AI that makes good decisions. Another is you want to be able to store uh, agentic memory, so the memory of your interactions along with your RAG corpus. And then you also want some level of governance so that because the agents really have no, in addition to, they have no discernment as far as what data is appropriate to use for what kind of use case, depending on what problem they're what the legal requirements are, what the firewalls you have, say, within different parts of a bank that shouldn't talk to each other, what the privacy controls are. So you want to be able to gate the knowledge that goes into the AI system as a function of, appropriateness, and that includes ethics and legality and privacy. So what are people doing? So here's an example from a leading gaming company that was building an application where they had 150 non-technical people, so business analysts trying to better understand their data so that they could advance the business and be able to ask really complex questions using natural language, um, and not be bound to a particular silo. And they implemented what I'm about to show on the next slide, an AI knowledge layer that is based stores data in a knowledge graph, where that, even just like in the V1, reduced the amount of time spent answering routine requests by 92%, and then got 10 times faster answers than traditional analytical methods for doing analysis. And some analysis even went down from doing like in weeks to being able to get answers in seconds. So I'm seeing this across a number of companies, and this is that same company and describing their data layer. So essentially, they have some conversational AI, which has an API layer into some multi-agent system. And then that multi-agent system needs access to knowledge. Here they called it a semantic layer. And then where does that data come from? Well, it comes from all the different silos that they have, either directly or maybe through something like Databricks or Snowflake or BigQuery or some other um, data lake or lakehouse or consolidation. And what the key insight here is, there's a new layer needed in the AI stack, namely the knowledge layer, to be able to meet all these requirements that we just talked about. And this layer is the layer that turns raw siloed data into connected, contextualized knowledge. And what this looks like generically is saying, look, instead of having different agents talk to different silos, or agents talk to like a data lake where I have a bunch of data, but it's like all the data in the known universe. I'm going to distill up the data that matters. So it might be 1% or 5% of the data in a lakehouse. And importantly, it connects it together. As much as data in a lakehouse lands all the data together, oftentimes you don't have relationships in the data to be able to provide the kinds of richer context that you need in an AI context. So this knowledge layer, what the function it provides is it holds structure, context, and meaning. It gives you a uniform memory and retrieval layer for agents so that agents don't get confused about, each agent getting a different picture of the world. It bridges human and machine understanding. So you actually want a knowledge layer that is not only understandable to machines, but they can be understood and verified by humans. And then it links and unifies your different data sources and objects. And you might ask, how does that fit into my existing um, data layer? And it's much like this customer of ours that I was showing earlier, this big gaming company. You essentially have your different data sources either directly feed the knowledge layer or feed, some kind of data warehouse, data lakehouse, which then feeds the knowledge layer. And the knowledge layer needn't have all the data. You really want to be able to, from a methodology standpoint, start small, tackle one problem, build it in a few months, and then you can always add to the knowledge layer as you go. Um, So what's the right structure for that knowledge layer? I want to point to a few recent statements from this year where Satya at Build said, okay, look, models are part of the equation, but it's just part of the equation. For anyone building an agent, you need to be able to have truly great access to the real-time web as well as to the entire enterprise knowledge graph. So an enterprise knowledge graph is the structure that you use inside of your AI knowledge layer to build awesome agents. And then one of the things you can do with this knowledge graph is to build RAG applications that don't do just vector RAG, but do RAG with a knowledge graph, which is known as graph RAG. So it's good and useful to do vector search, but you also want to be able to have access to a graph. Here's one from AWS reInvent. This one preceded that one by a little bit from Swami, who owns their AI and data portfolio, talking about how, again, a knowledge graph is the ideal way to store knowledge, and you really want an AI knowledge layer for your enterprise agentic applications. And just in the last couple months, I've been privileged to do the rounds with conferences that we in Neo4j have been running and have different customers stand up on stage and talk about how they've been able to successfully get to production with exactly this architecture. Walmart is one. They actually wrote a paper on this that's up on archive. I will link a little bit later, doing people operations across their 1.6 million employees. And this is one of 4 AI apps that are live and widespread throughout the company. Another one from Adobe, building an AI agent that thinks in connections, again, referring to the fact that context requires connections amongst the data in your domain and then across silos. Another one was from AbbVie, so large pharma company that is doing drug discovery using this approach. They've spent the last few years actually investing in a large system that consolidates knowledge into one place that now is just the perfect place to send all their AI agents. Uber has a config knowledge graph that they use when onboarding drivers in new cities to help them execute all the rules deterministically around. So giving agents access to detailed knowledge about what offerings are available in what city and what the criteria are. And then another example is Discover doing household marketing and behavior journey analysis. So customer 360 and customer journey. So this is, really becoming a tried and true proven approach that distinguishes the maybe whether you believe it's 5% or 10% or 20% of AI enterprise applications that are succeeding against the ones that are maybe getting a little bit more stuck in prototype mode, and you have a hard time meeting all the requirements to get to production. So again, characteristics of the knowledge layer and why graphs end up being a perfect substrate for this is you want a knowledge layer that can connect silos. So if I have my uh, all the various places in the enterprise where you have customer data, what you want to be able to do is have AI that can look at customers, but then, okay, what are the transactions that have occurred with customers? Let's link those together. What are the products that have been bought in the transactions and by what customers? Let's link those together. If I can always tie it into supply chain, let's say I want to do a promotion and promote products to certain customers that not only are desirable to the customer based on what they or members of their household have bought and not bought, but what is actually on the shelf or will soon be on the shelf, and so on and so forth throughout the company. So companies have all this knowledge that, in a way, like logically wants to be connected together, but really isn't, just because of the way organizations and data structures have come into being. Another thing you want is for an AI knowledge layer to be transparent. I alluded to this earlier, that you want it to be understandable to humans and to machines. So let me give you like a just really simple example of this. Let's say I'm trying to represent an apple. So an apple has all these different characteristics, color and shape and size and juiciness and crispiness and uh, olfactory sensation and so on. But let's say I vectorize that apple. The vector view is, it's useful. I can do vector similarity between apple and orange, or apple and tennis ball, um, or apple and car, and see that apple and car have nothing to do with each other. Apple and orange are a little more similar. Apple and tennis ball are still maybe kind of similar because of the shape and the size, but not similar in other ways. But you don't really have any way to know if, based on the vector structure or similarity operation, the why behind it. And so this is why complementing it with let's say, a declarative view in a knowledge graph can be really helpful. Is I can say, what are the things I care about in any given apple, um, and then track those, and then feed those to my AI system, and have that richness be available both to the AI system and ultimately to the humans that are looking over its shoulder. Accuracy is another big consideration. There's starting to be quite a few, in addition to just the real world case studies I mentioned, different evals out there showing how you're actually getting much better results by getting context from the knowledge graph and feeding that to the model. And there are actually two different ways that people use the knowledge graph. One is I feed context to the model and let the model reason. Then I still have some non-determinism and I don't have full explainability, but I know a little bit more about what went into the model. So maybe you could say it's a little bit of gray box explainability. The other thing you could do is actually, for complex questions, let's take this one. This was a slide presented by Adobe where they have some information security use cases where they have the topology and a bunch of information in a graph. And as human beings are able to ask more complex questions, the questions can get pretty complex. So here's one where it says, what is the number of unique devices used by the top 5 most active users with the highest login records in the country with the highest number of IP usages? So you can imagine like the SQL equivalent would probably bring together multiple databases and lots of tables, and your model might actually have a hard time generating this. And if you can generate the query, it's probably really huge and might take a really long time to run. And with the graph, they're actually able to have the model generate the query in a few steps and get an answer to the complex question. And coming back to reasoning, in this case, the model delegates the reasoning, the actual answer to this complex question over to the graph database, to your knowledge layer, which then computes this because it turns out this has an exact answer and you can arrive at it, and it's a pretty low latency operation. And then the role of the model becomes turning the human question into a database language question, and then taking the results and then just feeding it back through. Um, and what's a surprise to me, this is an example slide from Uber, but I've seen similar ones from other companies, including Comcast and Walmart and Adobe, like you just saw, that models are actually better for complex questions at generating cipher, which also, as a side note, is now an ISO standard in the form of GQL, which is a sibling language to SQL. So it's an ISO standard. Um, than it is generating SQL. So that came as a surprise even to me, being a long time graph person. And it has to do just with how terse the expression is of that question. Turns out that expressing that question in Cypher or GQL is relatively trivial, or let's say it's much simpler because the language lends itself more towards these complex connected kinds of questions. So what we're seeing in the field is a much lower error rate for models trying to take complex questions and support them through delegating the question down to the data fabric. Coming back to the explainability and discernment, so you want to be able to get, when possible, some explanation for why the model made a particular decision. And if you're delegating back as a query, then I have the query, I have the data, I can visualize it, I know exactly why I got a particular answer. And likewise, I know exactly what the underlying data is so that I can filter it according to access controls, like in this healthcare example where the doctor has access to a health diagnosis, but the customer service person talking to the patient does not. So here are a few examples. This is the one I mentioned that's been published. So here's a link to the um, paper out there where they talk about their HR use case and um, what the overall architecture looks like. But you can see here they drew it horizontally rather than vertically like I had before. But you basically have users with some agents, with a bunch of tooling, and then a knowledge graph on the right. Here's the example from Uber, where again, similar, they sort of did it from left to right too. You have your LLM provider. I guess to the left of this, you have the user, even with an agent, um, with a bunch of services and evals and so on and so forth, with access to the graph on both sides here. So let's go back and look at what AI challenges exist in the enterprise and to what degree we solve for those. So one is we all know AI can make mistakes. That's okay for lower stakes application, but it's oftentimes not okay for mission critical applications. AI is a black box. Again, that's fine for document summarization, meeting notes. Um, but if I have anything that's regulated or higher stakes, a lot of things that are customer facing, you want to be able to peer into the black box. And that doesn't mean that every single agentic operation has a human looking into it, but it means that as part of your QA process, or maybe after the fact, if something goes wrong, and you need to go and show someone on the business side or regulator like what actually happened, you can do that. Discernment. So this comes back to using the right data according to privacy, security, or other restrictions. And then lacking context, where we define context as being the signal, not just the noise, and having the connections out, maybe multiple levels out, so that you just don't have facts about a person or the things immediately around them, but a little bit more of the richer, say more than distance one, cause and effect and interactions. And, just through what we talked about, hallucinations you can solve by delegating certain questions to the graph, or just getting more rich context. Likewise with the black box problem, likewise with applying security and access controls and not having your model train on your proprietary data, but using it, using access controls inside of your data layer. And then, context is basically, the main thing you get out of a graph approach is being able to get context and causality multiple levels out. Okay, I thought I'd spend a few minutes before I wrap just talking about some of the building blocks that are out there for building a graph, because the big question that many people have is, all right, where does my graph come from? So it can come from usually either a structured or an unstructured source. So I'm going to show you some of the latest tooling out there for both. Here is Neo4j Aura is Neo4j's hosted service. There's a free version, and then there are 3 paid tiers with varying levels of availability, security, support, etc. Here I'm going to connect to Snowflake. I'm going to reverse engineer a schema on the left. I'm going to click a button, and what you actually now get within like less than a minute is an inferred graph schema where I can then press another button and just bring all the data into the graph, which I can then visualize. So this used to take our professional services team working with the customer like a week to go and do all that mapping. Now, thanks to AI tooling, you can now build graphs from structured sources much more easily. And then the other thing that's interesting, of course, is unstructured sources. So if we want to build a graph from unstructured, then uh, LMs actually turn out to be pretty good tools for at least doing like a 60% accurate V1 version of your graph, doing entity and relationship extraction from documents or transcripts. And then from there, you can do refinements. So let's take the Wikipedia page for Microsoft, which happens to be rather long. Let's bring it into, this is a tool called the LLM Graph Builder, which is both open source and there's a hosted version, which I'm using here. Let's tell it a little bit about what to look for. So, scrape this page and extract out entities that are people that look like they work for companies or companies that launch a technology or people that live a location, and then just go and build a graph and it'll do it. Then I can ask a question like, who's the board on the board of directors at Microsoft? It'll refer back to the graph before it goes out to its own internal trained knowledge or the World Wide Web and find what data was in the document. So it turns out the Wikipedia page specifically says, as of December 2023, here's the board. And I checked it, and this is correct. And you can click on where did the answer come from, and you can actually see the graph and get the explainability. So here's the board, and then you can see that some of these board members either at present or in the past worked for Microsoft. And then there's a larger graph underneath that. Cool. So if you want to learn more, there's a ton that's out there. Probably the first place I go is a place called Graph Academy, where there's a bunch of free training. So just search for Graph Academy or follow this link or have a QR code. Another one is Deep Learning AI. There's a short course on knowledge graphs and GraphRag, and we have a new one that was recently recorded, which should be coming out soon. And then there's a book called Building Knowledge Graphs, which actually just barely precedes the launch of ChatGPT. But nonetheless, so it doesn't include information about the latest tooling that I showed, but it's a good conceptual framework around like what kind of graphs do you have? Because you have a graph of the domain and a graph of your meaning, like ontology, and a graph of your vectors in your topology, and so on and so forth. So I covered a lot, and let me end there. And if we have time for questions, I'm happy to take some. Otherwise, we can move on.
Philip, thank you so much for this. This was amazing. I want to tell you my story. Um, you know, I worked at Walmart for quite a few years,
Oh, amazing.
and we championed graphs. My team championed graphs. So the word traversal was used very, very abundantly in
Hmm.
in the company. And we used Neo4j, we used other graphs, we built graphs by ourselves. And it'll be my company name is also called Traversal. Traversal
Cool.
AI, right? So it's Neo4j is the one company that understands what traversal means. So it's a bit of a origin story for me, because I truly believe that graphs sort of are, and that's what we have done in the past. Like I am a big proponent, big user, supporter of graphs in any form. I mean, and I also say not everything needs graphs, but things that need graph, they leave databases and everything else behind by leaps and bounds. We're working with one of the Fortune 10 companies, and what we have done is a very interesting implementation. We've used transcript information, like they have 10 to 15 million calls to the to the call center, and their transcripts on that. So we have created a knowledge graph from those transcripts. So somebody can ask, what were the top three problems in Q1 for all our customers?
Hmm.
So it can condense that information. So we've been at the cutting edge of Neo4j. We love to, I've spoken parallel to quite a few people from Neo4j, but I just want to say that it's it's an amazing product, and less people know about it. I know there's no question here. I'm just saying things.
Yeah, yeah, yeah. Yeah,
Right.
no, that's great, and it's very very cool to hear your history. And you're right, like for the right kind of data, which I see it as if your domain is complex, like let's say shaped like a network, it really comes down to the shape of the data.
Mhm.
Um, and do you care more about just like store and retrieve? Do you care about context? Do you care about causality? For me, those are the trigger words. And in a lot of ways, I feel like we've accidentally built a product that's really useful for AI in the way AI has turned up the last few years.
All right. Yep. Julie, let's head to the Q&A, maybe ask a couple of questions, and then we sort of, let Philip go.
Yeah, sounds great. So I'm looking at the chat. We have quite a few questions. Let me see. Someone asked, what knowledge graphs are best for certain industries?
It's Yeah. So in financial services, some pretty big ones are payment graphs, because by tracing through and looking at patterns in payments, you can actually really easily identify things that otherwise were nearly impossible to see, like money laundering or different forms of fraud. Um, Another one is in anything involving recommendations or trying to predict user behavior. It turns out, like there's been some sociology research there's a book called Connected, which speaks about this, that if you're trying to predict someone's behavior, you actually, and let's say you have the choice between serving up a bunch of facts about someone or serving up the behaviors and interactions of people, not their friends, or even their friends' friends, or even their friends' friends, who are people that they don't know them, their friends don't even know who they are. It turns out that your friends' graph, like their subgraph of interactions, is a better predictor of your behavior than is a bunch of facts about you, which is mind blowing. So, by the way, like the other takeaway is be careful who your friends are, um, and you're influencing people in ways that you don't even see. So it's quite empowering. Um, and so in recommendations, journey, like in entertainment, being able to predict what content someone might want to watch, patient journey, drug discovery, where I have the graph of biology and all the interactions, um, telecommunications. I just was at an event earlier and literally had a startup founder jump into my car and say, "Hey, I want to talk to you. Just let's talk on your drive home, and you can just drop me off at the train station and I can train back." And he had actually built his observability platform to do root cause analysis once I've had an alert and try to figure out like Kubernetes containers and services and what's going wrong and have agents figure all this out. That was all graph based because that is a very networked and connected domain. So pretty much those are a few examples from some of the top domains.
Wow, that's a great story. All right, so we have some more questions from any chat here. So I'm just gonna go with the first one I'm seeing. So can knowledge graphs be used to automate BI in business groups across finance, commercial, supply chain, marketing, and R&D in a life science company?
Yeah, yes, but what I would focus on is not trying to replicate the kinds of BI you already have, because there are a bunch of great BI to Looker and Tableau and business objects and so on and so forth. Like those are great at the kinds of BI that they do, which is more about like slicing and dicing and drilling down. Um, so what you want to complement that with quite often in say life sciences is what kinds of additional intelligence can I get from understanding the connections either inside of a highly connected domain or across different domains? We actually now recently used AI to create a product, or sorry, now offer a dashboarding product that you'll find like is just part of our standard um, UI and all the tools to be able to just click a button and say create a bunch of dashboards, which is kind of cool. The other thing that can be that's amazing in life sciences, I'll tell you a story about a one of our first pharma customers who had actually used Neo4j. They started with the community edition, which is open source, and then they eventually, obviously, for like more serious stuff, they moved to the commercial, like enterprise, or now they use the cloud-hosted version Aura. But what they did was say, let's take the biology of different interactions between molecules and gene expressions and proteins and enzymes and so on and so cells and so on and so forth, diseases and conditions. Let's represent that as a graph, and let's also visualize it as a graph so you can actually see the nodes and relationships representing the interactions. And now let's bring in a bunch of scientists, not data scientists, but like people who are where biology is their primary domain, and have them look at this and see their domain in a new way. And it turns out that was so powerful for them to actually see the interactions between a domain that they'd studied for many years that they literally like ran out of the room, grabbed their colleagues and said, I can see the biology. Like for the first time, I can really understand how this stuff works. So I'd say if you could extend BI with those unique kinds of insights and interactions and different kinds of visual expressions, along with the computational expressions, then absolutely.
Wow. I'm in awe of the answer and how you've put it together. Philip, thank you so much for your time. This has been amazing. Thank you. I know you had a busy time schedule and everything. It's an honor to have you. I have been a big, big, big supporter of Graph for the longest time. And I tell people, I teach across multiple universities and I run a startup and every one of them there's Graph. We have a dedicated chapter on just knowledge graph from Neo4j. I've
That's
also
amazing. Well, we should definitely talk more outside of the conference, but it's so great to meet
yeah,
here, and the honor's all mine. Really, thanks all of you for who attended and all those who hosted.
in my book on RAG, I've literally written a chapter on knowledge graphs, teaching
Mm.
how to use Cypher, and we've done a bunch of fun stuff. Anyways, Philip, thank you so much. Thank you so much for joining in.